Okay, hello. My name is Adam Bean. I'm from Germany, so I got lots of questions where I'm from. Germany, Munich. First time in Florida and Orlando, so it looks nice so far. So yeah, except the storms. So it was problem with the flight. And yeah, why the title? This was spontaneous actually idea during the call. But what I'm actually doing is more or less cloud native Java EE, Jakarta EE MicroProfile, and now a little bit Quarkus in all my projects, and larger projects and even startups. And the main problem with is NDAs, of course. I cannot talk too much about the startups in particular project, except one, which they say, okay, I can. So then I will just show you at least the website. So I still have fun with Java for years, really enjoy it. And yeah, the problem is we see, over and over, new stuff coming out, like, we learned about Java support at Kubernetes, so it's never get bored with Java. That's the problem. So if you would like, to have a quiet job, don't choose Java, I would say. It's too much going on. Interesting, ASFM is podcast. Why podcast? Because it's not always time at conferences to talk, too much about deeper with one person. So I had already a session with John Klingen and lots of interviews with, we have Tommy Tribe and Quarkus developers and all over the place, people I'm interested to talk with. Okay, learn once, never migrate. And actually, I changed the strategy for the session 3 times. The first time at the breakfast, then second time after conversation with John, and now my conversation is going to be completely different than usual, but see how it works. So first, this is a very new slide. It's 2 minutes old. Why Jakarta Java MicroProfile why they are actually successful? And this is the strange thing. People ask me, are you still doing Java EE? Who cares about Java EE? In my projects, everyone cares about Java EE, not about the name, about the results. And this is just like a complete, in conference I get asked, whether I use Scala or Rust or Go, whatever. And in projects, Java is popular like crazy. It's really, really popular. So, okay, so now, if you have questions, first Monday of the month, I try to answer as many questions as possible, but no emails. And from time to time, there are workshops. So, first of all, so make it a little bit larger. The cable is stable, you see. This is the first Java EE effect, so the presentations are working. So this is, they replace the cable, I have to tell. So, so first, set up Java EE project. This is an archetype. Let's call it J4K or J3K. It's also nice, but J4K is actually the idea. So, and what happened behind the scenes is a project J4K was created. By the way, the archetype was created by me. And the reason is not because it's very sophisticated. The problem is all archetypes I found about Java EE were too sophisticated. They had plugins who no one knew what they're doing, and you take a look what we actually are doing. So this is Visual Studio Code, a nice IDE. And what this is a blueprint for all cloud-native microservices right now, except Quarkus. It's a little bit different. But what we always do, we always pull together Java 8 and pull all MicroProfile on top of it. And the first thing I can tell you, no one cares about the distinction about Jakarta EE and MicroProfile. Most of my developers just use whatever is there, and whether it comes from MicroProfile or not, no one cares. The most important thing is everything is included in all major servers. I didn't care on MicroProfile at all for 2 years, so we had a conversation with John a lot. And I got interested in MicroProfile. And at this point, if the major platforms like Payara, which my clients used, Whitefly partially, Open Liberty fully, and Tommy, of course, where you can just download a server and keep it going. So the first thing what makes Java EE and MicroProfile successful is called in projects time to first commit. So it should take 30 seconds for setup, and then you should be ready to go. So what I did right now, this is my setup. If this takes longer than this, it will die. No one is interested in fiddling. We do Java 25 years, and my perception is the setup becomes more and more complicated without any reasons. I mean, we had the peak with Xdoclet. I don't know who remembers Xdoclet. You remember the beautiful Xdoclet, right? So, and now it isn't even that much simpler, In project, they're using super POMs and Maven plugins, and no one knows why. So in my projects, for instance, super POMs and everything else is forbidden. Why? There's nothing to inherit. So the idea is you get complete something. Let's call it J4K. So what I really hate is we have now 2 dependencies. So before microprofile, I only had this. So I could even remember what to write. Now 2 is already 100% more complicated. So in the perfect world, in 2 years, I would appreciate to have just Jakarta EE, latest, and I'm done. No one cares, and this would be the perfect setup for Java EE or Enterprise. Got it? So if questions? No questions. This is strange, in conferences, no question. Perfect. So now, how to run it? So I actually recorded for Red Hat a screencast about cloud-native Java. I use a lot of Whitefly, so I think I shouldn't use now Whitefly. I use this Liberty for now. And the Liberty, as always, runs in the most crazy setup. So as you know me, all dependencies which are includable are already included. So it's also my experience. What I do is I take everything to be simple at the beginning and then optimize later. For instance, I created another archetype you will see in a second for Quarkus, where I include all the dependencies because developers don't have to fiddle, which extension is used right now. For instance, we migrated recently a project from stock Java EE to Quarkus, and what we did first, we included all the dependencies to make it run, to make it compile, and then removed, then optimized later. So I think productivity is the king. So I would say in future, to be successful in clouds or not, actually no client cares about clouds at all, right? They would like to ship faster, whether it is cloud or sun, who cares, right? So what it means in the future to be more successful, we have to make everything as simple as unique as possible. Okay. Now, so Open Liberty is running. So and now to deploy, what I did. Are they JavaScript developers here? No. Okay, very good. So I did a workshop for JavaScript, and they asked me, in Java, why do you not watching, your source code and build automatically? So most of IDEs are doing this, but not like gulp back then. And I thought it's actually a great idea. So I built such a tool. It's like 7 Java classes, and I call it Watch. And what does is, as you can see, it watches the changes on my machine and pushes to all possible application servers. And I think it is already deployed on Open Liberty, the largest Open Liberty I can configure in 1 second. And so let's see. What should already work is if I go to 9080 port, 9080, this is the Liberty, hopefully. Yes, the old one. And then J4K, resources, and I think my default is ping. So, and now the application was deployed. And this is like, the worst possible experience, because on my machine I have some other stuff running. So this is like, the slowest possible experience. And what happens on every change? So if I change here and go here and say ping resource, and I say, this is not like Jakarta EE, rather the future edition is called just J4K EE or whatever, just for fun. And then we'll reload this. You see J4K. So, and what happened behind the scenes? What happens behind the scenes? The application was updated in 200 milliseconds, and more importantly, it was built entirely in 2 seconds, and the whole thin war, so-called, was copied 4 times. It was 3 kilobyte small. So the next important thing for cloud native is this thing has to be small. Why? Because we are pushing this in my average project, I would say 50 times a day to the cloud. If this is 20 megs, I'm too impatient. So I couldn't stand waiting 30 seconds until something happens. If this is 10 kilobyte, it is faster. The developer experience and productivity are king, actually. And this is what was supposed to kill Java in 2006 with Rails. It didn't happen that way, but everyone productivity, and this is actually what was bad really 2006, and we shouldn't forget that. So questions about that. So what this is the tool is like, is primitive. What happens behind the scenes, what this tool does is it watches the source file changes, finds Maven, does Maven clean install, and copies the word to the server. This happens behind the scenes. So there's really the, Quarkus experience minus 10 years, something like this, right? So this is no sophistication at all. Questions? No questions. So everything, so then means tomorrow everyone does, right, Java EE right now. So what happens now if we would like to push this to, let's say, Kubernetes, also known as, so what I actually wanted to do is to show you MicroProfile and Jakarta EE. I suppose you know everything, and there is another workshop all the day, so you will learn everything, all the metrics, MicroProfile and the stuff. And instead, I will show you how to push this thing, for instance, to a cloud. So there are different challenges, but what I, for instance, did, we use OpenShift S2I images for application servers right now. And Whitefly comes, ships with one, and there was no one for Payara. So just for fun, I will just to use it for Payara. So now, Minishift console, hopefully it runs. It always runs, but if I don't get the IP address, sometimes I do see nothing. So it really depends on the wireless LAN. And this is like the AirHacks project name. So it runs locally. And now what I can do, I can say Payara micro S2I. This is like script. I show you what happens behind the scenes. And J4K is the project name. And what happens now, it builds and uploads. As you can see, the deployment is already running. And in a few seconds or minutes, it really depends how hot my machine is. This was complete deployment of one Payara full with war to OpenShift. And actually, I saw hybrid cloud, private and public clouds. What are we actually doing in some projects? We are running all the pipeline in private cloud in OpenShift. But if we are done, you get all the Kubernetes YAMLs. You can actually export them and push into whatever cloud you like. So you can use your private clouds as a base and push it to public cloud on demand. So if I would like to scale this thing here, and would say, by the way, this is the route, so it should actually already work now with Payara Micro. So if I go here and say, what was it, J4, so this is the Payara, and J4K, I think it was resources, and pink, and it runs now on OpenShift. So if I would like to scale it, OC scale, I think, right? Scale DC replicas 2. Wait a second, where is my console? So scale, what?
CD instead of DC.
Ah, sorry. DC J4K. So it's scaled. So, and this is just, stock application server, very boring, but this is the reality in our projects. So what here is lacking, a delivery pipeline with unit integration test, system test, and so forth. Now, still no questions? No questions. So if you would like to have, let's say, metrics, just to show you this, what's interesting is what developers are doing. They are putting, here metered, and we get Prometheus metrics. So metered, and you get Prometheus metrics. But of course, if you do this all the time, you get all metrics who no one cares about. What you can do with MicroProfile metrics, expose business metrics like counters, business counters. And this is what we start with. So this is actually completely forbidden in my projects. I was in several task forces where clients asked me, we have plenty of dashboards. Please tell us whether they are good or not. And I remember there was one business project, and they showed me the garbage collector, and there was a diagram like this, and they asked me, is it good or not? So, okay, it looks nice, but I mean, it's nothing to do with your business, right? What I would expect, like conference metrics, how many attempts to registrations were made, how many frauds were, or something like this, how many successful transactions, unsuccessful transactions, this should be exposed, which is actually extremely easy with MicroProfile. And how to do this. And again, there is no distinction for me between Jakarta EE. So Java 8 was the old stuff. The Jakarta is the fully open source. And there will be no distinction in my projects between Jakarta EE and MicroProfile. This is one thing. And of course, you can have a happy project with just MicroProfile. But at the beginning, why not use both and see whether you need all these specs that you can then optimize later. And by the way, the JavaScript community does it for years, and they call it a tree shaking. It's not like they're fiddling from the beginning. They take everything. If the Angular downloads, I think, 25,000 JavaScript files, but only no kidding, 25 to 35,000 JavaScript files are downloaded, but the production is just like 5K is pushed with 2 files. So why I should premature optimize my environment as Java developer? I don't care about that. I would like to have like Ruby-like or Rails-like experience, just go with it. And we have it already. This was my fault. Very good. So now we have the ping service. And the ping service could be return something, return J4K. Oh, J3K is also okay. So this is the prequel, should be J3K, and the next one is go J4K, right? So, but the thing is, what you get for free is you can say add inject and metric registry, and then I think it's already working because I included the full microprofile. I don't have to think, is it metrics, fault tolerance, where it's coming from? I'm really not interested. Metric registry, and there was registry type, and the type is going to be application. And now I can say here registry counter and call it like unusual position attendees inc. So what this will do, it will increase a counter, and this is actually a really good idea for instance, stress test, because in stress test I would like to see not how many transactions are processed, but whether actually something happened. And this is also a very important thing for the business department, because they also know for the business experts, they're absolutely not interested to tell them I had 5 rollbacks and 3 commits. What they would like to see is know how many successful use cases were actually performed. Now, needless to say, what I also can do here, I have my circuit breakers and all the patterns you can imagine, sequence breaker, fault tolerance. Also funny anecdote, 2 years ago in my projects, everyone wanted to have historics in Java EE projects. And the reason was there were several or a few conferences in Germany, and there was Netflix, and they just talk about historics, and that was really nice, and they just wanted to have historics. And I asked them why, and there was always circuit breaker. They really like to have circuit breaker. And the justification for the circuit breaker was they would like to have fallbacks. And I said, okay, how a business fallback looks like. Let's say we have payment. We would like to pay something. What is the fallback of paying? Not paying, paying later. What is your fallback? And the crazy thing is, I reviewed a lot of Java EE project afterwards, and there were no fallbacks. Even worse, the fallbacks through runtime exception. So they were even it was worse than before. And of course, then there was no more historics. Netflix pulled the plug with historics. So now all the projects migrate from historics to microprofile. And microprofile is a different story. I don't have to think in advance to include historics. The historics is already there somewhere, or not, I don't care. I only have the annotations, complete different story. So I can use the circuit breaker, bulkheads, whatever I have on demand without upfront cost or evaluation. Got it? And the funny story is in Germany, we are just removing histories. You could spend now 4 months and get a good money just to migrate it away from histories. Okay, it's a boring job, but yeah. If you like, go to Germany, you get something interesting to do. Deleting code, who is Java EE? Okay, questions so far? So I would like to skip that part, it will work. And if not, go please to the workshop with James. I had the chat, I will show you everything. So we had a sync up. Now about Quarkus. I think it's the right time to talk to really to cloud native. So what is Quarkus? So Quarkus, it looks, so what you create. So this is how you would create a Quarkus application. So the first thing is, I don't have to think about my Maven archetype. It's not actually an archetype, it's also very fast. So if I start it, I get questions what to build, and group ID J4K, let's say, Quark, and set a project version, REST resource, and hello. So if I go to Quark and build it, so what happens behind the scenes? So forget the tests, we're deleting them at the beginning, So I get a runner, I can launch a runner, so it's already done. So what I told you before is like, fat jars and Uber jars, no one interested in. Yeah, it took, I think I saw Quarkus the first time in March. And what I was curious is what is actually inside the file, because it is like 90K. It is larger than my war, but are smaller than Uber jar. And long story short, this file contains references to lib. And in lib, you get lots of dependencies. Depends how many dependencies you are declare. They are downloaded here. So now the question is, what's the difference, right? And for me, as I saw this is actually genius. So what happens here is exactly what happens in application servers. There's clean separation between the business logic and the platform. So this is the business logic, and the platform is somewhere. I'm not interested in all the dependencies. They are somewhere. And by the way, the cost of dependencies is nearly zero. I don't know about you, but in all my cloud projects, the costs of a Docker registry are negligible. So it's not like we have to save megabytes to push to the registry. So what it basically means is, in this lib, this would be the base layer in Docker. We push it on every Quarkus release. This would be the future model. To the private Docker registry in a cloud, OpenShift, or whatever you have. It is everything almost the same. You always have kind of container registry, let's tell it, and Kubernetes, right? And so this is the cloud model for everywhere. And the cool story is my incremental pushes would be incredibly fast. Okay? Still questions? No. The next thing I saw is I recognized sorry, I have to stay here. So if I got here or here, the exception happens, illegal state exception. So what I actually wanted to tell you, I was afraid now from this thing. What was talk about? My last sentence? The base image, exactly. So the base image should be as small as possible. It's pushed to the cloud several times, and the business logic is really, really small. The smaller the better, the faster the deployment. Okay, so what you also saw is the time to first commit. So the time to first commit is very fast, even faster than my maiden archetype. I get everything out of the box, and everything can be built and performed in no time. Why this? Because of the separation. Now, if you think about the application servers, what they did for years is they have the wars, and the wars were pushed and deployed to the application servers. And if you think about this, it only makes sense in shared deployment model. And now I know what I wanted to show you is, I'm curious, Adam Bean, one war, one server. So it was 6 years ago. Since 6 years or even longer, what I said, the whole shared deployment model is actually stupid. What we should do, the application servers are small enough, so we can have one application server, just use it for productivity reasons, what you saw, and push on the application server the wars, and this just for productivity reasons, right? So this is this 1-1. But if you think about this, it doesn't make any sense to have hot deployment on any kind of deployment in one-to-one relation. Okay? Because why? Why you need deployment if there's only one microservice per application server? And as I saw this, I thought that the Quarkus developers recognized that and say, what we can do, we can deploy before. And this is what I really like in Quarkus. What Quarkus actually does is it deploys during the build time. Correct me if I'm wrong. So it reads as many, the deployment descriptors and annotations, mingles everything together, exposes as many classes, the dynamic classes as possible, to have no, overhead at runtime. So what it also means, if you think about this, you don't have to ship, XML parsers, directory scanners, deployers, class loaders to production. So the server becomes leaner. And if I saw Quarkus, like the first time in the history, I see something actually, which clear advantage. This is like Java EE next. So what it did, which this deployment model you saw with OpenLiberty was great. We can hot deploy, and it took 1 second. But it doesn't make any sense in cloud native era. What makes sense is prepare as much as possible at build time. It should be fast. And then ship it once to production. Okay? Questions? So So what Quarkus is and why I'm interested, and actually not why I'm interested, why most of developers interested in Quarkus is it is like the application server taken one step further and optimized whenever possible, but with no clear disadvantage like using Uber jars or fed jars. So for developer experience, what you can with Quarkus absolutely do, you have your own embedded server. So this was just explanation what happens with if you build it. What you can do, you can run it with Quarkus dev, and what Quarkus dev does, it would run a dev server if the port is open. And now every change is like, now you have almost like browser sync or Angular experience. So now whatever changes here gets redeployed automatically. So on every, so if I go here and say localhost now 8080 / and I think it was hello, standard message is per default. And you have the hello. What you also get, you get metrics are not installed. You would get metrics if I would install the metrics. Okay? So now, one step further, I have plain Quarkus with CDI and REST easy. None of my project has CDI and REST easy. So what I did, I always do the same as with OpenLiberty. I put everything I can. So set up Quarky project and call it Quarky. And this is, of course, orders of magnitude larger, but the thing is, developers don't have to care. So now I have my Quarky project, Quarky. And what it just is, I was lazy. It is Quarky. It looks for me like Java EE. So whatever could be useful is inside. So as you can see, I have JSONB, I have REST easy, JTA transactions, security, the scheduler, which is really nice, Swagger UI, Hibernate validator, WebSockets, Java WebSockets, fault tolerance, and all the microprofile because I use them all the time. So we stick with that, and afterwards, if not needed, we can remove the dependencies anyway. So it's just other way around. So premature optimization is not the root of evil, but slows us down. So what it means is, so if I'm here and say Maven Quarkus dev, what you will see is hopefully no error. But you see all the dependencies. So now it's the slowest possible Quarkus experience, but for me it's like Java EE plus experience. So I have everything I can rely on. So what it basically means is, in the Quarky project, I can go here and add, of course, metered is already there because the extension is there. So for me, it's almost no distinction, and application scope would just work. Application scoped. So and of course get metered. So what it means is if I now invoke localhost 8080, this is this is not Payara, it's just cache. So they are already metrics activated. They were not available before, and now they are active. Okay? So now, next thing, what I really like, this is a cool hack, the Docker native. So what Quarkus can do, and just go to the Quark again, is smaller, Maven clean install -p to the native thing, and can create a native image on your machine. So it works fairly well recently. And what you get is one all-included image, which I would say for me is comparable to Go. My understanding is this image can be immediately started, and there's only dependencies on the minimal Fedora image, which is incredible if you think about this. The cool story is I can use my old programming model as Java EE developer and build library, which will be about 20 megs of size. So there's absolute productivity without any disadvantages, except of course this takes longer time, but this can happen on Jenkins. I don't have to do it over and over again. I really don't care about this. This is part of my pipeline, and even part of my asynchronous pipeline. It doesn't have to happen all the time. Now, of course, the problem is, if you run it on your machine, you get Quarkus for Windows, for Mac, or for Linux. And what you would like to have is one Quarkus for everything, right? So the cool hack is the Docker native. So the Docker native container image, what it will do is it will build the native Quarkus image in the Docker container and package it as a Docker container, and now you can run it everywhere. So you get one Linux binary running in the container, and you can start it from wherever you like. And this is interesting. We did some evaluations, and there are some problems building in a Docker on Windows machines. There was all the Windows. And what we did, we built, somewhere then you can just run the Docker container from whatever you like. Okay. So this is the native, and you also get a container with JVM. What I usually do or will do, you see that this depends on Alpine OpenJDK. I will usually create a base image with all the libs and push it once to the cloud, and just watch the Quarkus releases and push them more frequently, and then just push the business logic. Okay. So now, so what happens behind the scenes? So if we switch to the Quark, and there's the runner. So if we check the size, you see this is 20 megs of total size. So it's absolutely portable on Macs. So there is no JVM, no dependency to JVM. It's just self-contained binary. And this is the runner, which is 90K. And now, Java minus jar, do the Quark thing, one snapshot jar. Runner, sorry. Should be the runner. So activity, and go here and search for Quark. No CPU memory, not Quark, rather than Java. So, and they are a little bit, I will have to kill this one. So now we see that the total size is 100 megs of the JVM part, which is already remarkable small, right? But I say, okay, it's optimization, but I wouldn't care that much, because I have to say memory was never that big issue in my projects. What's really remarkable, how much traffic you can handle with few application servers. Most of my clients have 2 to 10 application servers, and they have sometimes 20,000 transactions per second. No problems at all. So not everyone is Google. You have to remember that. No, it's not like in Germany a small insurance company will run 100 Kubernetes clusters just because they were on a conference. So now we have 100 megs of the Java size, and what I would like to compare it with, and see it started in 0.7 seconds, and now what I can do, I can run the Quark 1.0 runner. And it started in 0.07 seconds. And now I would like to search for the runner. And here is it. And this is 8 megs. So I would say if someone has a memory problem, this is worth evaluating. It's not like you are saving 20% of the memory. It is completely boring in my eyes, because if you have 10 microservices, and I don't know about USA, but in Germany, RAM is not that expensive. I bought for my 64 gigs of the most expensive RAM, and I spent 300 euros. So this is, so you would save, let's say you have, 10 microservices, full application servers. Each application server will have 500 megabytes. So how much is it? 5 gigs of RAM. Try to buy it. So it will save probably, I don't know, 2 euros or something. But if this is order of magnitudes, where you have small services who will start and stop, have to start and stop all the time. So this is a thing you will save, this is not even 10% of the total size. So this is worth exploring. And what I like the most, I don't have to use strange programming model who no one knows. What I show you actually, I started with stock Java 8, added a little bit microprofile on it, then switched to Quarkus, extended it a little bit. Then you have the productivity, and you can decide whether you go to the extra route. And whether this is performant or not, I mean, we will find out, right? We have stress tests, and we'll see whether GraalVM is fast enough, in Java, so you will see it. And if not, we save a little bit. So I mean, and this is the future, because it's reasonable. And wait a second. What I also like is, from the beginning, is developer experience. Because in Quarkus, if I start a project, what I really like from day one, it was actually, otherwise I wouldn't even look on it really. So if I do this, again, and just do whatever. This is okay, yes, yes. So you could already, for instance here, navigate in this directory, launch your application with Maven compile Quarkus. You get hints what to do next. And if I create ASDF, of course, and Maven Quarkus list extensions. So I get list of all the extensions with the name, and I say, okay, if you would like to add the extension, you use this. And if I use the extensions with format full, which is, I get actually links to guides where you can just copy and paste, and they are actually good enough for Hello World, which is hugely valuable for the enterprise. As no one reads documentations, it should be included, you know. So you should be able to start fast from day one, and then if you have questions, go here, extend, and so forth. Sorry, you had a question.
Two questions. In terms of the memory limits and everything, is it aware of Docker memory limits that occur on that? And then secondly, as that container continues to run and everything, does the memory fluctuate? Does it change? Does it go up and not go down or anything like that?
The Quarkus is based on GraalVM, and so the native part will behave like a native image. Whether it will fluctuate depends on the app, and I don't have 2 years long production experience because Quarkus is too new. And we would just test it. So this is the thing. It's not whether it's production ready or not. I will try to find before that. In my stress test, it behaved well. So this is what I can tell you. Is it aware of the Docker? I suppose not, because it's not Java. This is Java, but like a binary image is the same aware as I would say a binary Linux image. But this is just, you should ask the Quarkus or Graal developers. And with the Java minus jar, you get this is just a Java process. So you get Java, which is optimized, right? And yeah. And by the way, what's also confusing a little bit with Quarkus, the extensions, you don't have to do this. So in one project, we had a legacy project which talks to host databases, also old IBM irons, and we need specific drivers. So we just included the Quarkus dependencies to the POM, right? And we couldn't use the GraalVM, but we got the jar, which was good enough for my client. And if you really like to use, the GraalVM power, you will have to use to write extensions, and they are actually not as bad. So I wrote one for fun, and you have to expose classes which are dynamically loaded. This is the basic task. So this is so time is up. Any other question? So I hope what I tried to show you, that actually the programming model is the most important thing. Application servers moved from actually servers to runtimes. Why? Because server would serve multiple apps. Now it serves exactly one app. Because it only serves one app, we can optimize, which is the best possible example is Quarkus. So there is no deployment, nothing needed, and everything happens at build time. And by the way, I recorded a YouTube video. What I did is, no time for that, on purpose, I introduced some CDI errors, and you get the errors at build time. Because Quarkus will find out, unsatisfied dependency errors or ambiguous dependency errors and build time, and not at runtime, which is actually a great news, right? Because fail fast. The earlier I get the errors, then I don't have to wait until the application server boots. Okay, any other questions? So I did completely different. I wanted to hack all the time, but I wanted to show the evolution in my eyes. And Quarkus is widely misunderstood. It's not like another funky framework. I think this is something else. So, thank you.